The topic for today is going to be software-defined storage, and you may note that I think in the past some of our presentations, most of our presentations, have been product-centric. We're going to take a little bit of a different turn today. We're going to talk about software-defined storage in generic terms, in primarily non-vendor specific terms. And the goal is hopefully to help all of you, whether you be customers, end users, perhaps resellers, or IBM folks, help you understand why this sea change is important, why it's disruptive, what's with all the marketing hype and the FUD and everything else that's going around, and basically from no matter where you approach the opportunity to help you maximize it. So first we're going to talk about what is software-defined storage, and then a little bit about who needs it and why it's important that we talk about this now. So I am, let's see, I'm presenting not so much as an employee of IBM today, but as an industry expert in the field. And so I would just let you know that what you're going to see today is not necessarily the opinion of my employer. Okay, so first of all, a little bit about me. Now, I work for the System X business at IBM, soon to be Lenovo, but prior to that, I was 30 years in the storage, enterprise storage, and SAN industry. All right, so let's jump into software-defined storage, now that you have a little bit of a perspective on my background and what I've been doing. I felt that it was important for us to talk at the users group about the definition of software-defined storage, because it's one of the most overhyped and ill-defined technologies I've seen in my 30 years in this business. And when something is that heavily hyped and it's getting that much attention and all the press and so on and so forth, it's usually because of one of two things. Either it's really, really good, or it's really, really scary to a lot of people. And by scary, I mean disruptive to the industry in general, or maybe both. First of all, I wanted to share with you a little bit of storage market perspective. And from a server perspective, let's take a look at how the market has valued storage versus servers in some recent acquisitions. A lot of you might know that Fusion IO was recently sold for $1.1 billion to SanDisk. I'm also guessing that most of you on this call know that the IBM System X server brand, bearing in mind that IBM is the company that invented x86. Anyway, the IBM System X brand was sold for $2.3 billion to Lenovo. But what a lot of people don't know is that the LSI storage adapter and silicon business, LSI is the company that makes the RAID cards and the SAS expanders and a lot of the silicon that has anything to do with storage. That business sold for $6.6 billion about the same time that System X sold for 2.3. If that gives you a perspective on how big a problem storage is and what the market opportunity is around storage, I think that'll kind of set the tone for a case I'm going to make as to why this software-defined storage thing is so important. Before the IBM PC came out, there were other PCs, but nobody ever put the storage into the PC. Let's look at the Apple II there on the right. You see the floppy disks. That was an external subsystem. And that was true of pretty much all the other PCs of the day. None of them had internal storage. The OS would boot from ROM, and then when you had a disk drive attached, you'd load a separate disk operating system from that floppy drive. Next thing that happened was that when IBM introduced the PC with internal storage, pretty soon some smart people had those things connected to networks, and the internal storage in a PC enabled the very first quote-unquote server applications, and those were file and print. Some of you who've been in the industry long enough remember that once upon a time, network attached storage was a Novell file and print server. and then a company called NetApp came along and essentially created a category that they called NAS. And basically what NAS was is file and print without the print. But the very first x86 servers were file and print. And that was because they had the ability to integrate copious amounts of storage that could be shared through that network interface. Well, the next thing that happened was PCs evolved into application servers. This is when we started running databases on them, client-server applications, so on and so forth. And about this time, when PCs really started to take off as application servers, the external storage oftentimes needed to be shared. And so physical PCs deployed as application servers could now be connected to something called a SAN, a storage area network, which allowed many servers to share this increasingly expensive external storage. And this was a sea change in the industry. It was very cool, and especially at a time when all servers were physical. Another thing that happened following the introduction of the SAN was it enabled all of the storage to come out of the servers, and when all of the storage came out of the servers, then we could shrink them down into a blade form factor. And so really, what a lot of people don't realize is that it was SAN technology that enabled the rise of the blade server market. Over time, though, storage has migrated back to live inside the server. And there's a lot of good technological reasons for this. You know, applications always want to do their storage as close as possible to the processor, which means being as close as possible to the fastest bus that connects the processor. And applications also like to do their processing closest to the best metadata. And both the file system and the application metadata live in the server. To give you a sense for why it's important for storage to live inside or directly attached to the server, think about this. A single PCIe attached commodity RAID controller, the LSI controllers that everybody sells today, with its cache, can talk at 6.4 gigabytes per second. And when we talk about response times, we're no longer in the realm of flash. We're 100 times faster than flash because that DRAM write cache, right? It's dynamic RAM, that DRAM write cache that is backed up by either SuperCap or flash or whatever. But that DRAM write cache responds in microseconds. And DRAM, especially on writes, is, you know, typically 100 times faster than any kind of flash. You know, and then you think about the number of cores. You know, we're not only moving from an environment where we had, you know, one server in one physical box, but we're also in an environment where we're putting more and more and more cores in a socket. And now we're, with the latest Intel platforms on a 4-socket box, we can put 60 cores in 4 sockets. And, you know, that hardware and the applications that are running on it don't want to get to their storage over Ethernet. Too much latency, too much distance, too much stack, and too much cost. And this also allows file system and application metadata to stay in very close proximity to the processor, which is where all the action is. In the meantime, though, the SANs have become increasingly slow in comparison. You know, PCIe bus speeds have increased faster than Ethernet or InfiniBand. Memory subsystem speeds are increasing in both raw interface rates and also in memory subsystem concurrency. And, you know, if you do the math today, a typical SAN deployment, I'm not talking about the high-end EMC stuff or the IBM DS8000, but a typical SAN deployment, like, you know, maybe even a Compellent or a V7000, your cost per terabyte can be 20 times more, and your cost per IOPS can be 100 times more than locally attached storage. So these are kind of the trends that are acting to encourage, I guess, storage infrastructures to move back inside of the server box. So does this mean that there's a future without SANs? Well, you know, I spent nearly 30 years in that business, and I've watched this for a long time, and I believe the answer is yes. You know, SAN storage isn't dead yet, but it is starting to smell funny. Analysts are predicting that 90% of all data storage will be direct attached or server internal before 2020. Gartner says the advantages of traditional high-end enterprise storage arrays will disappear within the next 3 to 5 years. And if you think about it, the companies that invest most in infrastructure and build the largest infrastructure on the planet, they have never used SANs. I mean, you know, Google's very first infrastructure was designed around cost, and it was based 100% on server internal storage. And you will not find a storage area network in any Google data center, in any Amazon data center, in any Microsoft data center, and in the vast majority of any public clouds. So when we talk about a future without SANs, I'd like to share with you one example. You know, software-defined storage is a buzzword. Everybody's applying it to everything. But before it became a buzzword, IBM was working with SAP, and we used our own software-defined storage. By the way, we're not immune to this. We've renamed GPFS, so, you know, General Parallel File System is now software-defined storage. But what we did in our SAP HANA implementation, and I think IBM probably owns still about 60% of the SAP HANA scale-out market because of this, is we were able to eliminate the SAN by bringing the shared storage infrastructure into the server hardware. Our current SAP HANA software-defined storage implementation is enterprise class. It runs on the Intel E7. It eliminates the external SAN by replacing it with a shared storage infrastructure implemented in software. And so I think that this kind of development, even though it actually came before the software-defined storage hype cycle, this kind of development points to the direction of this trend. Increasingly, performance-sensitive applications and applications that require special attributes from storage, increasingly it is becoming more and more difficult to implement that with a traditional externally attached SAN storage device. This is probably the best illustration in my mind of how the Gartner hype cycle works. Now, this is very tongue-in-cheek, and it's a little bit laughable, but it's actually very accurate. Because when you talk about, for example, you know, social media, okay? Social media has just been this huge buzzword. And so in the classic Gartner hype cycle, we have a technology trigger, and the excitement in the market builds and builds until you get to the peak of inflated expectations, which was pretty much right after the, you know, Facebook went public. And then you start to approach the trough of disillusionment. This is where all of the overblown claims and, you know, it's going to change your life and it's going to change the world. This is when some of those claims start to literally fall flat. So now you're in the trough of disillusionment. But over time, you start to realize that some of what was there in this hype cycle, some of what was there is true. And so the slope of enlightenment is when customers start sorting out the wheat from the chaff and get beyond the hype cycle marketing. And so you see things like, you know, now it's back to blogging, right? And then when you get to the plateau of productivity, and this is really the punchline here, you know, email is really where it's still at. When I log on to Facebook, I see that maybe 1 or 2 out of my 50 or 60 close friends on Facebook, 1 or 2 of them might be online. But virtually every time I get an update from somebody that I care about on Facebook, it comes to me by email. If that gives you a sense for how the hype cycles work and what the plateau of productivity ultimately looks like, a lot of times it lacks a lot of the hype and the glitz and the glamour that you heard about during the peak of inflated expectations, and it probably looks a lot more like stuff you've already been doing for a long time and you just didn't know it. When we talk about what is software-defined storage, let's bear in mind first that we're in the middle of a classic Gartner hype cycle. In fact, I would call this one a hype storm. And in the middle of a hype storm, everybody is trying to use the term software-defined storage one way or another. I have immense respect for the people at NetApp and what they have done. Their products are incredible and they're excellent, but NetApp is a poster child for hardware-defined storage. So when we when we look at companies like NetApp trying to get out in front of this curve and redefine software-defined storage in terms that are favorable to them, well, I think we'll move along here to the next slide. You'll see how this continues to happen. So then there are some independent analysts who have defined software-defined storage. I actually like IDC's definition pretty well. It's close to the mark. And IDC basically says that software-defined storage is any software stack that can be installed on commodity resources or on off-the-shelf computing hardware. This is good, but it's got a couple of problems. It essentially captures the idea that software-defined storage is anything but hardware-defined. But if that's true, then shouldn't software-defined storage also encompass the storage area network, right, which is what we use to talk to storage? And if that's true, is it necessarily the case that software-defined storage has to run on x86? I understand what IDC is getting at here. What they're trying to say is they want customers to see or to interpret the idea of software-defined storage as a piece of software that you can run on anybody's hardware, okay? But doesn't necessarily, in my mind, need to be x86. So now we have the Storage Networking Industry Association. This is a group that I've belonged to for many years. Have a lot of friends there, and I've enjoyed a lot of their work over the years. But you have to understand that the Storage Networking Industry Association represents the traditional SAN vendors. Now these are companies who, as you'll see in a little bit, are going to be getting most of the disruption from software-defined storage. So, of course, you can expect that the Storage Networking Industry Association is going to define software-defined storage in such a way that it can run on proprietary hardware. Well, if we go back to the IDC, you can see that IDC saying that it can run on any hardware, and SNIA saying it can run on proprietary hardware. They're 180 degrees apart. And then SNIA goes on to say that the definition of software-defined storage includes a self-service interface for provisioning and managing virtual instances. Okay, that sounds more like cloud to me. So I think SNIA, here's a bad pun, but I think SNIA is a little bit cloudy on software-defined storage, and I think it's mostly intentional. So then you have the vendor definitions, okay, and you've got established vendors all in a race to kind of control the messaging, right? They want to get out front. They want to tell people what software-defined storage is before people figure out what software-defined storage is. This is pretty much everybody. This morning Google reports that an explicit search for software-defined storage and definition yields 1.9 million results. Several weeks ago, IBM came out with a book, Software-Defined Storage for Dummies. Well, you open up Software-Defined Storage for Dummies and you find that it's really a book about GPFS. And so in that case, IBM is going to define, in their own best interest, obviously, they're going to define software-defined storage as in terms of GPS functionality. And of course, the description there, automated policy-driven application-aware storage services through orchestration of underlying storage infrastructure, all that stuff, that's exactly the same description as GPFS had before it was called software-defined storage. So, I don't want to be accused of picking on other vendors. I'm going to be doing plenty of that during the rest of this presentation, but we're all guilty. So there's an elephant in the room for all of these storage vendors, and here's what it is. If you go back 10 years ago, an EMC Symmetrics had custom-designed hardware. If you go back 10 years ago, Hitachi Data Systems had custom-designed hardware running on a RISC processor. In fact, if you didn't have a custom-designed hardware storage controller, you weren't really considered a player in the enterprise storage space. Well, kind of very quietly over the last 10 years, every storage vendor, and I mean every one of them, has rewritten its software stack to now run on more or less generic x86 hardware. So all of these software stacks that are out there, right, proprietary software stacks running on proprietary hardware that is no longer proprietary for any good reason, but all of these software stacks already run on generic Intel x86. The elephant in the room is that what customers see, and what customers are looking for is that the magic in software-defined storage will be when the storage software gets disaggregated or unbundled from the storage hardware. And so we'll go through a few more definitions here, but I think that's where we'll wind up. Quickly, a reality check. The truth is that all storage is both software-defined and hardware-defined. Okay, let me give you an example of hardware-defined storage. Every disk drive, and I mean whether it's in a laptop computer or in an SSD, every disk device uses a standard that comes from the American National Standards Institute. It's called the ANSI T10 standard for a storage device. So every storage product is at least partially defined by that hardware interface, that standard hardware interface down at the disk drive level. So the difference is, the only question is whether the software is married to vendor proprietary hardware. In other words, does my storage software run on industry standard hardware? And by industry standard, I mean either x86 or an ANSI T10 storage device or an ANSI T13 SATA drive or any of these others, you know, either de facto or organizationally driven standards. That's the only question. Does the storage software stack run on standard, industry standard hardware, or does it require vendor proprietary hardware? So there's our reality check. So after all of that, I've managed to come up with what I will call my semi-definitive definition of software-defined storage, which, boy, if you try and say that 3 times, it's a mouthful when we talk about you know, arguing over definitions of software-defined storage when it's really right in the name. It's software-defined. But I think this is a good take, and it's really mostly the same as the IDC definition. But I took it a little bit further. I said that software-defined storage implements the elements, and I mean all the elements, of a traditional network storage environment in software. And it relies on industry standards to avoid dependencies on vendor proprietary hardware. Essentially, that means that if I've got a storage stack, I can run it on pretty much anybody's industry standard hardware. That's fairly simple. But there was a piece of that I thought was probably missing. So I came up with my definitive definition. And my definitive definition is, in addition, software-defined storage may also include any number of other enhancements, application-specific priorities. It might be cloud provisionable. It might be all of these other things. In other words, software-defined storage encompasses a whole lot. But at the core, it's got to be vendor independent. So just a few examples. I think that there's a couple flavors of SDS. Some software-defined storage presents Ethernet ports, might present fiber channel ports, might present them as iSCSI. But some software-defined storage looks like a SAN switch. It looks like a storage device, so I can plug a server into it, a physical server into it. So examples of this, and some of these companies have been around for 10 or 15 years. Falcon Store has been making software-defined storage for more than 10 years. Data Core came out in about 2000 with a stack that runs on Windows. By the way, Falcon Store runs on Linux. IBM's GPFS, which has now been marketed as the GPFS storage server. Even Microsoft Windows storage server meets the software-defined definition if you apply the duck test. So part 2 of the duck test is, what if I connect some virtual servers to it virtually inside of a virtualization host? Does the software-defined storage solution look like either SAN or NAS? and provide shared storage to my virtual machines. And here, some examples here are Nexenta, StorMagic, vSAN, Microsoft Storage Spaces. There are a number of others. Not all these are very new. For example, StorMagic's been around since 2008. And Microsoft Storage Spaces has evolved along the way. It's mostly renamed, but it's been around for a while. So again, I think the message here is that the idea of software-defined storage is not all that new. What is new is I think we have a market that is more ready to accept it, and we have broad-based proof that Intel platforms can now run the highest availability storage on the planet. I'm going to stay vendor agnostic today, but I wanted to show at least one picture, one example, just so that you can see how, let's see, I won't, this is probably the simplest implementation of software-defined storage, and it is what I would call a software-defined storage pure play. StorMagic, for example, does not sell any hardware. You can buy their software, and they're an IBM partner. They're partnered up with, I think, all of the other server vendors as well. But I use StorMagic as an example because it pretty much gives you a very simplistic look at how this all works. The server on the left and the server on the right are hypervisor hosts. They could be VMware, they could be Hyper-V, doesn't matter. And they run any number, and this is a high availability cluster, by the way, and they run any number of virtual machines, any number of applications. One of the virtual machines on that hypervisor host, however, is the StorMagic VSA, the virtual storage appliance. And that virtual storage appliance sits in a high availability implementation on each of those two servers. It talks to all the disks on each of the two servers, and it replicates or mirrors that storage across the two hosts. Then what the VSA does is it serves up an industry standard storage interface. I think in this example it's iSCSI, but it serves up an industry standard storage interface to all the virtual machines. So what's happened here, and this is the key with StorMagic, is not only has the storage moved into the hypervisor space, moved into the server, but the storage network has moved into the hypervisor space. I think it's important for users and for sellers and for influencers and for really everybody on this call to understand a little bit of the subtleties around disruptive technology. Disruptive technology was a term phrased by Professor Clayton Christensen from the Harvard School of Business. And I remember one interview recently, he almost regrets ever using the term because it's been widely misinterpreted along the way. The context in which Clay Christensen defined a disruptive innovation was this. Disruptive technologies are innovations that disrupt existing models for making money. In other words, a disruptive innovation is something that comes along and does something differently, better, faster, and cheaper than what the mainstream market has grown accustomed to. And so when you wind up with gigantic industries, with industry stalwarts like EMC, NetApp, IBM, and so on and so forth, gigantic industries who have everything invested in the status quo model for making money, a disruptive innovation is something that comes along and messes that up. Okay? So there's the one thing to know. The one thing to know is that software-defined storage is not disruptive in terms of application use cases. It's not disruptive in terms of technology adoption. It's not disruptive in terms of anything that can be seen or felt from the user's perspective, with one possible exception. A disruptive technology can often wreak havoc on organizational headcounts. It creates sometimes shifts where, you know, the department that used to manage the telephone system in any given corporate headquarters, well, guess what? That entire department went away when it became voice over IP and all that moved into the networking group. Okay? So disruptive technologies can have that impact on users, but in terms of business value, use cases, so on and so forth, the rule is that disruptive technologies do not disrupt users. However, if you stop and look at what software-defined storage is poised to do in the marketplace, you understand that there's good reasons why there are 1.9 million hits on Google today regarding people, you know, talking about the definition of software-defined storage. It's massively disruptive. In fact, I would say that software-defined storage is more disruptive than virtualization itself. If you look at the amount of revenue that is potentially going to be impacted, industry revenue, and industry profits and business models that are going to be impacted, I think the software-defined storage is probably more significant than virtualization. Think about this. If you make your money selling, building, designing, administering, supporting, converging, or otherwise cashing in on expensive SANs, SDS is going to be disruptive. If you're Cisco and you really bet your business on the future convergence of storage area networking with data networking, if you've really built your business around that, and all of a sudden that SAN that you've spent so much money figuring out how to converge into the data network, all of a sudden that SAN kind of vanishes in a puff of virtual smoke and disappears into the server space. Well, you can expect that Cisco is watching this technology very closely because it's hugely disruptive. The other thing is that if you're selling hardware-defined storage on white box x86 servers at very, very high margins, SDS is going to hurt you. Vendors know who they are, and I will say that nobody's immune from this. One of the true pieces of genius in IBM's acquisition of XIV is that XIV implemented a very, very, very sophisticated software stack, and they implemented it on generic white box x86 servers connected to low-end SATA hard disks. And the magic of XIV is that it proved that the magic was really in the software. The market wasn't ready for that kind of a software-defined storage play. I think it was necessary that XIV be shipped on, you know, gosh, can I use the word proprietized? Proprietized x86 hardware. But you know, XIV is a case in point. Another case in point is EMC's entire product line, all gone over, now runs on x86, and at various points in time it's been made by various motherboard vendors. And NetApp and SDS and pretty much everybody runs on Intel hardware. So, but the main thing is, if you've built your business around a vendor lock-in equation between proprietary hardware and proprietary software, if you've built your business around that equation, you stand to be disrupted. And so I think that's why SDS is at the same time extremely exciting. It's an extremely exciting business to be in right now, but it's also really, really scary, and it's got a lot of people up in arms. So one of the things that Clay Christensen talked about when he talked about disruptive innovation, you know, he had a prescription for mainstream players, big companies like IBMs and EMCs and so on and so forth. And his prescription was, you know, you need to do what IBM did when they invented the PC. IBM knew that the PC was going to be disruptive. So they tapped a small group of people. They sent them down to Boca Raton, Florida. They gave them their own P&L. They gave them wide latitude, and they got them as far away from headquarters in Armonk, New York as they possibly could. IBM, as you might know, is the only mainframe company that survived the onslaught of mini computers. It's the only mini computer company that survived the onslaught of PCs. All of those other vendors went away. So there was a clear prescription. There was a clear prescription and a proven formula for how you handle disruptive innovations. You have to get in front of them. You have to be willing to eat your own children. You have to face them head on, and you got to make sure that the mainstream business doesn't squash it like a bug. Well, there was another approach to how a big company can deal with a disruptive innovation. And the other approach is to squash it, or delay it, or defend against it, or create FUD about it. So what we see in the marketplace right now is a bunch of entrenched big industry storage vendors who are trying to create as much confusion as possible to slow down the adoption. Some of them are trying to redefine it. Very complicated techno speak, right, to make it just sound incomprehensible. And people just throw up their hands and say, well, I guess the status quo is just as good because what they're showing me really isn't much cheaper, and I can't see how it's less complicated. Then another tactic might be to buy up lots of little companies for unnamed prices and issue a lot of press releases. In other words, this is just smoke and mirrors, right? This is just a lot of, again, creating confusion. And you know, there's a little joke in here. I'm sure that somebody at NetApp would be mortified if they saw this. I'm sure it was just a typo and it got by. But this is the front page of NetApp's solution brief. If you go to their website, you'll find their link for software-defined storage. You click on the link and you find their paper on software-designed storage. So I got a big kick out of that. So we've talked about, you know, what software-defined storage is and what it isn't. Let's spend a few minutes talking about who needs it. We'll talk for a minute here about the benefits of SDS. Let's just summarize the benefits of software-defined storage as a platform. I think the main benefit is adaptiveness. And you know, this is about 14 years ago. IBM's Institute for Business Research, they came up with this white paper on adaptiveness in e-business. And they said that adaptiveness was critical because, you know, everybody likes to talk about agility in business, but they don't tell you how do you be agile, right? And, you know, if you want to be agile, it depends on the architectures that you build your business around. So adaptiveness is a term that kind of quantifies the adaptability of an infrastructure, and gives you a sense as to how you make your infrastructure more agile. So software-defined storage allows customers to choose storage software according to application requirements. Okay, and this is because storage software decisions are application-driven, right? My storage software is going to be very different if I need to do a file and print server. You know, for a file and print server, I might use Windows Storage Server. But my storage software for an SAP HANA, you know, in-memory database or an SAP HANA cluster is going to be something very much more sophisticated, something like GPFS. But likewise, software-defined storage allows users to choose their storage hardware specifically tailored to business requirements. Now, storage hardware decisions are attribute-driven, right? What do I mean by attributes? Attributes are, you know, how many nines of availability do I need? What kind of an environment am I in? A controlled environment, you know, temperature controlled data center, or am I out in, you know, 1,800 remote offices, back offices, or maybe I'm out in, you know, 2,000 Home Depot stores in a back room somewhere where I could, you know, have a forklift go through the wall at any time. So I think the main benefit for users is that software-defined storage enables infrastructure adaptiveness, which increases organizational agility. Other software-defined storage benefits: performance and innovation. Let's think about this for a minute. I think this is hugely important. Software-defined storage dramatically increases the pace of innovation. Software-defined storage vendors can implement new features and functions without firmware or hardware development. The other thing is, and this is something a lot of people miss, software-defined storage can ride the leading edge of Intel processor development cadences. Right? That means, you can make a decision on any given day, and you can make sure that you're running the latest and greatest Intel software, or even the cheapest and most appropriate Intel software. You don't just have a one-size-fits-all software platform because you happen to choose an EMC VMAX or an IBM V7000. Hardware-defined storage, all of it suffers from the Jasper-Forrest syndrome. Jasper-Forrest is the name of a chip, an x86 chip. The first one was a version of Celeron, but it's named after a petrified forest in Utah. And the reason that Jasper-Forrest is named after a petrified wood is because storage vendors had a problem. Storage vendors had a 5-year hardware refresh cycle, and they couldn't keep up with Intel's 18-month tick-tock cadence, or even now faster than 18 months. So the Jasper-Forrest syndrome came about when all the storage vendors says, look, Intel, you got to give me a processor. If you want me to use Intel for my storage architecture, you've got to give me a processor that you're going to guarantee I can continue to buy it for at least 5 years. Well, the problem is that processor is never going to be leading edge. So hardware-defined storage today all suffers from the Jasper-Forrest syndrome. It's always running far behind the Intel performance curve on what I call Intel petrified wood. I lost the fourth bullet here, but let's see, and I repeated the fifth bullet. So I think, but I think I've apparently made my point there. Let's continue with software-defined storage benefits. Lower cost. A lot of people want to talk about lower cost, but really I think it's down on the list. But the lower cost is reflected primarily in that it reduces or eliminates the need for physical SAN infrastructure. The other aspect of lower cost here is that when vendor lock-in gets eliminated, competition is enhanced. So you're going to have a hardware vendor competing for your software-defined storage infrastructure, and you're going to have a software vendor competing for your software-defined storage infrastructure. And they're not going to be playing, any kind of proprietary linkages off of one another. Here's another thing to consider. Look at the reduced support costs. When your entire storage and storage networking and your application infrastructure runs on the same hardware, you're only supporting one piece of hardware where you were supporting at least 3. Okay. Think about the impact of that, not just on efficiency of the support model, but think about the fact that you will never, ever again have your storage vendor pointing the finger at your server vendor, pointing the finger at your hypervisor vendor, pointing the finger at your high availability, clustering software vendor. That can't happen anymore in a software-defined storage context. I think that's huge. Finally, reducing the complexity. Switch SAN function and storage protocol traffic, when it moves into virtual spaces, guess what? I don't have to think about converging my storage network and my data network anymore. Okay. Now, again, I'm not saying that SAN is going to completely go away, but SAN is going to look a lot more like mainframe business. It's going to become very, very special purpose in very, very limited environments over the next few years. And I think that software-defined storage is going to find some homes. So we move now to who needs this. Well, the earliest software-defined storage adopters are already in production, and they're in environments and applications where SANs already don't make sense. Small businesses, doesn't make sense to have a SAN anymore. Remote office, back office, and distributed environments, doesn't make sense anymore. Applications that require special storage attributes like SAP HANA and other in-memory databases, it doesn't make sense to try and design that on a SAN. And things like VDI infrastructure. I want to back up for a second and talk quickly about remote office and back office. Ben, how are we doing on time here?
We have 30 minutes left, and
okay.
No other questions at the time. I just want to remind the attendees that if you do have any questions, please use your GoToWebinar side panel. Please continue, Eric. Thank you.
Thank you. So in these remote office and back office and distributed environments, I want to talk about one place, the classic hallmark example of a disruptive technology is that it takes root in a fairly innocuous or fairly obscure marketplace that nonetheless can have the potential to be very big. So when software-defined storage first started taking root, one of the places that I have seen it over and over again is in large retail distributed environments. Okay, let's just pick a retailer XYZ. All right, or what the heck? Let's just do HDX, Home Depot. Coming into a major refresh cycle in 2011, I think it was 2012. I think it was. Home Depot had some number of servers, and they were attached to a small iSCSI SAN, and they were, managing. So, and the iSCSI SAN had to have its dual controllers. It had to have its batteries. It had to have all that care and feeding that goes along with that. But that was the shared storage, and then there were a couple. I think actually three or four servers in each Home Depot store to do the various things. They looked at refreshing that, and of course they could certainly buy another small iSCSI array. All the vendors sell inexpensive iSCSI arrays. Another option was to maybe use a small NAS device, because some of the databases have gotten better at talking through the file system stack. But what they settled on was software-defined storage. What they were able to do is replace the 5 boxes or the 4 boxes that they originally had, which is the little iSCSI array, and a number of servers. They were able to replace that with 2 servers, each server with its storage, and a software storage stack that essentially, I mean, when you think about it, if you've got 2,000 some odd stores, and you've got maybe 8,000 servers, boxes, right, out there, you're going to have a lot of failures. When you can turn 8,000 boxes into 2,000 boxes, guess what? You just cut your per box failure rate to a quarter, right? Because the reliability of any system is determined by the number of parts and pieces that are in that system. So not only did Home Depot collapse all of that infrastructure down onto a couple of servers with locally attached storage, but by reducing the overall parts count, by reducing the complexity, reducing the energy costs, and so on and so forth, they saved massive amounts of money. Now, I'm going to stop with Home Depot, but I could name 4 other big retail customers at that same scale who have adopted this same approach within the last 12 to 18 months. And I can name a couple more today who are getting ready to pull the trigger. This is a classic hallmark, again, of a disruptive technology. It takes root in a market that a lot of vendors would think is insignificant. Okay, I'll tell you, EMC wasn't going to build a product for this market, and IBM wasn't going to build a product for that market. And I don't even think NetApp would be able to build a product for that market. And so this is, this is that, again, hallmark example of a disruptive technology. It takes root in a small market that the big guys generally don't care about. Okay, but the other hallmark of disruptive technology is that as that technology advances and matures and it proves itself in many thousands of installations and so on and so forth, it improves, it gets better, it gets refined. And so it's not too hard a prediction to make, but I'll make it. In the next 24 months, the higher-end SDS solutions are going to penetrate the data center, and they're going to attack traditional SAN space. Software-defined solutions based on Intel E7 will appear for the very first time. The Intel E7 is Intel's flagship, highest availability, mission-critical processor. Isn't it funny that there isn't a single storage vendor anywhere? I mean, I suppose you could count IBM if you count our SAP HANA solution, but there isn't a single enterprise storage provider anywhere that has leveraged the mission-critical high availability characteristics of the Intel E7 platform. I just think that's endlessly interesting, and it's one of the reasons that I jumped into the server space. So, why now? Software-defined storage. This is clearly my opinion, and I'm honestly expecting to be challenged on this, but I think that software-defined storage is going to be everywhere. I've already said, I believe it's true, SANs are going to go the way of the mainframe. You just can't have your expensive storage resources be that far away from the critical processor and memory resources. It just architecturally doesn't work. Gene Amdahl would have told you that. Jim Gray would have told you that. It has to, I just believe that the SANs are going to go away. The other thing is that software-defined storage, despite all the hype, really isn't new. What's new is the critical mass. What's new is that for 10 years now, the enterprise storage guys have been proving that Intel x86 infrastructure is robust enough for the most critical storage applications. The small business and the robo use cases and uptake are now well established. Fundamental technology underlying software-defined storage is generally perceived as mature, and for anybody who hasn't perceived it as mature, after they see a presentation like this one, they're going to understand that it is mature. And so if you point it out to them, users will already know that their enterprise class SAN storage is running on x86, so it takes away the fear factor. For all of these reasons, I think the software-defined storage adoption curve and industry uptake over the next 24 months is going to be even faster than that of server virtualization. And I've got some pretty big bets on this with some other people. I'd take additional bets, but I need to be able to cover my bets, so I'm about tapped out there. Okay, so this presentation has been as much as possible vendor independent. But I do have to talk about why SDS and IBM System X are particularly well suited for one another. I think everybody here is aware that the acquisition of the System X x86 server business from IBM by Lenovo was approved by the US government a couple of days ago. And the thing that's important about that is that when you look at the System X brand when it's no longer part of IBM, we're going to be part of Lenovo. We're going to be the only server company that doesn't have a storage business that we need to protect from disruption. We don't have a storage business that we need to protect. We don't have a SAN business that we need to protect. So we're not only going to be uniquely positioned from the standpoint of, Lenovo knowing how to go to market, right? I mean, they took the IBM PC brand from the depths of also ran to #1 in the world, and everybody who said that Lenovo wasn't going to be able to do this, Lenovo's looking at all of them in their rearview mirror now, especially Michael Dell, right? But so it's not just about Lenovo's proven ability to take these technologies to the next level and grow them on a global scale. It's about the fact that as really kind of a startup server vendor within the Lenovo company, and within Lenovo being a company that doesn't have that disruptive innovation fear factor, you can expect Lenovo to be particularly aggressive in not only pursuing the low end of the market, right, but also in pursuing the high end of the market. And we've got some of the best platforms to do this with. First of all, System X, we have the best and the densest storage server offerings. We can get more storage into a two-use server space than any of our competitors, and at the same time as we do that, we can also give it the what's called the ASHRAE A3 environmental rating. We're the only ones that build a storage server with the full-blown ASHRAE A3 environmental rating, which means that we can withstand continuous operation at 104 degrees Fahrenheit. that makes us particularly appropriate for remote offices and back offices. We have the best platform for multi-tiering in software-defined storage. We've got a Model X3500 server that is the industry's only server that can mix 2.5-inch, 3.5-inch, and up to 6 PCIe flash cards all in the same server chassis. There are massive, massive opportunities and applications that require tiered storage for various kinds of applications, and that is our flagship model for tiered software-defined storage. The other thing we have is we've got the industry's best platform, the industry's leading platform, the most market share in the Intel E7 mission-critical space. We're on our 6th generation of mission-critical x86 using the Intel E7 family, the Intel high-end family. We've invested over $1 billion jointly with Intel. That's more than all of our competitors combined on development of the high end of Intel's mission-critical processor family. And that server, the X3850X6, is going to be a flagship platform for true mission-critical enterprise-class software-defined storage. It will, if my prediction is right, and by the way, I don't have a view into IBM development, but if my prediction is right, it will be the first ever enterprise-class storage platform to run on Intel E7.
Here, with that said, there was a question that came in. What makes the E7 platform perform better than an E5 platform in the storage?
Sure. Sure. It's mostly around the RAS features. Let me back up and say it this way. When Intel got out of the business of Itanium, they weren't killing their high-end business. The Intel E7 is the new Itanium. So if you look at a 4-socket implementation of the Intel E7, right? Draw a picture in your head with 4 processors in a square, connect them all to make a box, and now connect them with an X across the middle. You see that from any one processor, you can get to any other processor in one hop, right? You cannot do that on the Intel E5. The other thing the Intel E7 has is something called machine check architecture recovery. If you do a Google search on, or a YouTube search on MCAR and Intel, what the E7 processor has is a feature that detects hardware errors, normally uncorrectable, unrecoverable hardware errors. And in this one particular video, they show the injection of a hardware error into an Intel E5 box and an Intel E7 box, both running VMware. On the left side of the screen, you'll see that the entire VMware host and all its VMs purple screens immediately and crashes dead in a smoking heap. On the right side, you see the Intel E7 processor. It withstands that hardware error, corrects it. It shuts down one of dozens of VMs and reboots that VM and doesn't purple screen.
Hi, in this short video, I'm going to show you a demonstration of machine check architecture on the Intel Xeon E7 series processor and how it's utilized in VMware vSphere 5. In the video, I have 2 identically configured Intel Xeon E7 series processor servers. The only difference is that the MCR feature has been disabled on one of them. As you can now see, we have both servers running and I'm using the tool to inject a hardware error into each system. You can see straight away that the server does not have MCAR, has crashed, showing a pink screen. All of the VMs on this server are now offline. If you compare it to the server which has MCR enabled, you can see that the hardware error has been contained and has only affected the VM that was running in that memory location. The other VMs are still running and not causing any disruption to your customers. MCR is a feature that is only found on Intel Xeon E7 servers. Thank you.
So if you want to understand the difference between Intel E7 and Intel E5, Intel E5 is the volume market. Intel E7 is the mission critical market. Intel E7 is designed to compete with IBM's Power. Intel E7 was designed to replace Intel's Itanium. and Intel E7 was designed to compete with Sun's SPARC processor. I think it's, I'm not sure if I've answered the question, but it's mainly around the robustness and the bulletproof nature of the platform. By the way, the Intel E7 processor includes memory protection technologies, memory error recovery technologies, and so on and so forth. I mentioned that IBM has spent more than all of our competitors combined in joint development with Intel on the high-end stuff. A lot of what Intel has included in E7 are IBM mainframe innovations, like ChipKill, right? So ChipKill was a memory protection device that was originally introduced in IBM mainframes. It's included in Power. And with Nehalem EX for the first time, it made its way into the Intel E7. So all of those highly robust reliability features live in E7 and are not found in E5. Meanwhile, the entire enterprise storage industry is running on E5 and not on E7. Scratch your head on that one. One more thing on Intel E7. If you look at in-memory databases, and we'll take SAP HANA for an example, the key critical aspect of an in-memory database is it has got to have the most reliable, most error-resistant memory subsystem that you can possibly have. So when you go, any of you who are familiar with SAP's HANA implementation, you go out to their website, you will find that SAP HANA is only allowed to run on Intel E7 processors. Now, there's a little bit of irony there. Here's SAP, right? They're building an in-memory database. The purpose of an in-memory database is to make IOPS stop happening, right? Because you're doing all your, all your data accesses in RAM. But SAP seems to understand that that kind of a platform belongs on Intel E7, while the industry's quote-unquote enterprise class storage industry doesn't seem to pick up on that.
Hi, I'm Rob, and in this short demonstration I'm going to show you one of the new features of the Intel Xeon E7 processors. What I have running here is an SAP database on one of the new Intel Xeon E7 processors. This is running a 4-way configuration, which gives you 40 cores and 80 execution threads on a single box. This in itself is impressive, however in this video we are going to focus on the new machine check architecture enhancements. Machine check architecture was introduced in the Intel Xeon 7500 processors about a year ago. At the time we showed you how it can be used to prevent an OS from crashing from hardware failures. In this video I'm going to show you what can be done if this functionality is extended to the application level. The SAP database I have running here has loaded its entire database into memory. This is a very common practice these days to speed up certain databases. However, in the case of an uncorrectable memory error, this practice could lead to an application crash and even a database corruption. The window you see here displays a table stored in memory, and it allows me to run several SQL queries on the database. Note that the normal query finishes in about 1000 milliseconds. If I now corrupt the memory space occupied by one of these tables, you'll notice that the Linux kernel detects the machine check exception and signals the application. If I now rerun the same SQL query, you'll notice that it takes a while longer to run as it has to recover the corrupted memory by loading the table from disk. After about 9 seconds the database is fully recovered and the application continues to operate as normal. Thanks for watching this video. If you'd like to see more of these videos you can follow me on Twitter at Intel Server News.
So anyway, I think it's very significant. I ended this slide with just a little note. It says, it's almost like we planned for this. And I'll tell you one last story because it ties into the E7. After almost 30 years in the storage business, I was looking at the trends. I'd had a lot of different roles. I'd done a lot of things. And I'm a geek in the geekiest sense of the word. I mean, I read Christensen's Innovator's Dilemma book like it was a mystery novel. It's just fascinating. I love the way technology develops and so on and so forth. But I was working as a contractor for IBM in a storage business development gig, and I heard about EX5. and I looked, and that's the previous Intel E7 based platform. And I looked at the memory subsystem, and I said in that moment, I said, this is the future of storage, right? It's IBM's innovations around the memory subsystem and Intel's implementations around the memory subsystem, combined with the trend where all these storage stacks are moving to x86. That's the thing that got me to jump from storage to servers. So anyway, I've had to answer that question for a lot of people. Many of you may not even be asking it, but just thought I'd throw that in there. Any other questions, Ben?
Perfect. No, not at this time.
Okay. I owe anyone an apology.
Oh, there's one other question coming in here. Will IBM and Lenovo be releasing anything along the lines of HP left-hand DSA? I know you don't have any insight into engineering,
Sure.
of course.
Well, we already have. It's based on a many-year-old product called GPFS. So I was actually involved with the guys who developed Left Hand out in Colorado. You know, Left Hand was always aimed at the very lowest end of the market. And what happened is Hewlett-Packard bought that business, and then they had a few other acquisitions, and the left-hand storage business didn't fit in the storage portfolio. So rather than just kill it, because Left-Hand was one of these companies that they were just implementing a storage stack on generic, they were using Supermicro servers at the time HP bought them. Rather than just flush the acquisition because the storage, the Left-Hand storage didn't fit into their current portfolio, they did something really brilliant, which was they just repackaged it to run on generic server hardware. And the reason I say it's brilliant is because that's what IBM did with SAN volume controller in 1999. That's what IBM did with GPFS in 1998. So do we have anything? We absolutely do. It's called GPFS Storage Server. But I want to take this opportunity to address the question another way. System X under Lenovo, we're in that position to embrace this trend no matter who the vendor is. You know, HP talks about how VSA will run on anybody's hardware. We're happy to provide the hardware for a VSA, you know, an HP cluster. We're happy to provide the hardware, and if we go head-to-head against HP on the hardware, you know, we'll have a vigorous discussion about how our environmental performance is better and how our storage engineering is better and this, that, and the other thing. But I think, you know, I'm going to, let's see, if IBM as Lenovo, if we're really, really going to embrace the benefits of software-defined storage on behalf of our customers, then we really got to be Switzerland, right? We really have to play the whole game, which is, you know, the server storage software and the storage hardware should be independent of one another. So, you know, I don't speak for anybody at Lenovo. Okay, so all I can say is my recommendation to Lenovo would be don't do it, because you make a more credible case to your customers. That whole story around adaptiveness enables agility and how it's standards that tie it all together, that whole story starts to fall apart when you start, you know, proprietizing the technology. So the answer is yes and yes. Yes, we have something that's called GPFS Storage Server, and you know, yes, we're going to embrace the market head-on with everybody, VMware especially. You know, I haven't mentioned a whole lot of vendors here. I don't know that I want to mention too many because I know I'll miss some. But you know, there's a lot of vendors in this space. It's an exciting space, and I think that there's going to be a lot of specialization. You know, just like StorMagic has specialized around, you know, small office and remote office and back office. And GPFS is specialized around the highest availability and highest performance applications. That covers the low and the high end. Nothing higher than GPFS, but I think there's a lot of room for innovation in the middle. Sanbolic has a Melio file system been around for a number of years. It was always software-defined storage. It's just now their marketing guys have to rename it. Again, Falcon Store, StorMagic, yeah. There's a lot of action happening. Lot of excitement in the space, and I don't think we want to fence ourselves off.
I should also mention that we have VMware vSAN partner members at IBM.
Oh yeah, did I thought I mentioned VMware, but I think I mentioned it on a slide. But yeah, VMware is exciting. You know, the other thing about HP's implementation is it requires 3 nodes, right? If you notice in the slide that I included with StorMagic, I wanted to show what a baseline implementation is. StorMagic has done something pretty cool, which is they can do it on 2 nodes because the tiebreaker node, right, the one that prevents the cluster from getting a split brain, the tiebreaker node is designed to run elsewhere, either off-site, on-site, on a virtual machine, on a laptop, or whatever. The quorum for StorMagic does not require that 3rd node. So again, that makes them very, very powerful in the entry space, right, when you don't have to have 3. If there are no other questions, I'd like to ask a question of the audience. Ben, I don't know if you can do this. I just kind of like to get a show of hands. I think we have some end users, some clients. I think we have some IBM resellers, and I think we have some IBM employees. Can we get just a kind of show of hands?
What's the question, Eric? Sorry.
Oh, I just how many let's start with how many end users do we have on the call? I don't know how the conference software works. Maybe it doesn't. Maybe it doesn't give us an opportunity to do that easily. What I was going to get at is specifically, I guess, from our end user and our reseller community. I'm guessing that some of you have some ideas about applications. Obviously, nobody's going to mention, company names or anything like that, but applications or ideas where this might be appropriate. How many people see this solving problems in the VDI space?
Currently have about 2 show of hands here.
Yeah. Is it possible for us to just open the mic up to let people speak out?
Work on it here. It looks like attendees would have had to enter a pin in order to be unmuted, so no, unfortunately, it's not at this time here. Not an option. Okay, at this time, Eric, did you have any other questions? Oops, sorry, Eric, you were muted.
Yeah. I don't have any questions. I just wanted to, let's see, I just wanted to put my email address in here. As IBM transitions to Lenovo, the IBM email addresses are going to get turned off at some point. They won't forward, so I'm going to provide the email address for my consultancy.
All right. With that, I'll mention again, there will be a wiki update to our virtual user group that will include links to the slide deck from today, as well as a recording of the session. That should be out there within 24 hours. And I will also send a follow-up email to all attendees with that information as well. So with that, we'll go ahead and close today's session. Thanks, Eric, again for your time. It was very informative and valuable information. So with that, I'll go ahead and close the call. Thank you.
And I appreciate the opportunity. Thanks, everyone, for coming.